Hello again to another Agakala React, and we're watching Earth Doesn't Orbit the Sun from Sci-Show Space. Sci-Show, not sci-fi, Sci-Show Space. And just go and see. And actually, short, it's only 3 minutes long. Weird. I thought that was
In
longer.
1687, Isaac Newton famously wrote that, quote, "For every action there is an equal and opposite reaction." In other words, a force in one direction is always met with an equal force in the opposite direction. It is Newton's third law of motion and one of the foundations of modern physics and astronomy. But it has an odd implication, that technically the Earth doesn't orbit the sun. Now, at first glance, Newton's third law seems intuitive enough. You can lean on a wall because as you exert a sideways force on the wall, it pushes back on you. Fish can swim through water because as they push the water backwards, the water pushes them forwards. But when you consider all of the implications, things get a little weird. This same principle holds true for gravity, which you can think of as like a rubber band pulling any two massive objects toward each other. The strength of that pull depends on both the masses of the objects and the distance between them. More massive objects pull harder, and the closer two things are, the stronger they feel each other's pull. But no matter what objects are involved, gravity is always a two-way force. So as the Earth pulls down on you, you also pull upward on the Earth. Now that little pull isn't gonna do much to the Earth since it is so massive compared to you. So it's easy to imagine that the Earth is the only object doing the pulling, but technically it's not. Similarly, as the sun's gravity pulls Earth around it, the Earth pulls back on the sun just the tiniest bit. As a result, the sun doesn't just sit still while the Earth goes around it. The two bodies orbit each other around their shared center of mass. That is known as the barycenter. If you imagine there's a rod connecting the center of the Earth and the center of the sun, the barycenter is the spot on the rod where if you put your finger there and let go, the two ends would be perfectly balanced. Now, because the sun is 333,000 times more massive than the Earth, the barycenter of the system is pretty close to the center of the sun. The Earth is kind of a tiny planet. The sun is only 1,000 times more massive than Jupiter, and Jupiter is much farther away. So the barycenter of Jupiter and the sun is just outside the sun's surface. And while no other planet can yank the sun around quite like Jupiter, all of the planets exert a small tug on it, and all of those tugs add up. In a 2020 study, researchers basically pinpointed the barycenter of the whole solar system, taking into account the masses and distances of all the planets. The barycenter moves as the planets do, but when they measured it, it was just outside the sun. So as the planets move through their orbits, the sun also traces a little circle of its own. Most of the time, this effect is minuscule enough that astronomers can basically ignore it and carry on as if the Earth and the other planets do simply orbit the sun. But the effect isn't completely negligible. In fact, one way astronomers discover exoplanets is by scanning the skies for stars that wobble like our sun. Other astronomers use this knowledge to make more precise measurements of the distances in the solar system, and that's useful because unexpected changes in those distances can signal the passing of a gravitational wave. So what might sound like just a weird piece of trivia actually affects how astronomers search for other worlds and the universe's most elusive signals. Thanks for watching this episode of SciShow Space, which was brought to you with the help of our patrons. If you'd like to get involved in helping us make videos like this one, you can get started at patreon.com/SciShowSpace.
SciShow Space. Okay, that's cool. I never knew that. The wobble, the sound is wobbling. I like that word, wobble. So that was cool. And that was definitely something new to me. And it's interesting. Kinda knew that. Like, obviously, I probably did hear about it because it's kind of like rings a bell in my head about that, but I wouldn't be able, like, if you told me the barycenter where is that, you ask me, I mean, I would have no clue what that is. So, yep, that's what it is then. And yeah, thank you very much for watching. I'll see you tomorrow. Bye.